Okay, today is going to be the shortest video ever. I'm going to try and do it in one take. Okay, derivative of inverse trig functions. That's what we're doing. So we want to add these rules to our list of things we can differentiate. So if we've got an inverse sine function of x on some constant a, then dy dx is 1 on the square root of a squared minus x squared. Okay, so if a was 3, this would be 9 minus x squared. Done. 1 over the square root of 9 minus x squared. Okay, same for inverse cos. If we had x on a, let's call it 5 in this case, then dy dx is negative 1 on the square root of a squared minus x squared. So we'd have 25 minus x squared. Finish. Okay, what if we have y equals inverse tan of x on a, then dy dx is a on a squared plus x squared. Now, I encourage you to have a look at why this is. There's a derivation of these formulas in your textbook. Do you need to know the derivation? No, but you do have to know how to use it. Okay, so it is good to know. So maybe look that up. Okay, let's do an example. Look at that time I saved by writing it out before pressing the record button. Okay, let's have a go at this one. Y equals inverse sine of 2x on 3. Okay, let's change this to inverse sine of x on a, right? So if I put this 2 down the bottom, it's going to be 3 on 2. So a is equal to 3 halves. Therefore, dy dx is going to equal 1 on the square root of a squared, 3 on 2 squared. Oh, not plus. Almost made a mistake. Minus x squared. There we go. So that's the answer. But we might be able to do some simplification here. Let's go 1 on the square root of, that's 9 on 4 minus x squared. Let's make these fractions add up. So we'll get a common denominator here with here. So I'm going to go 1 over the square root of 9 on 4 minus 4x squared on 4. Okay. Then I can put these together. 1 on the square root, I should make it a little bigger, of 9 minus 4x squared all over 4. And now I can take the square root of the 4, flip it up to the top. So I get, hopefully you can still see that in the screen. I might put the answer over here, just in case I'm running off the screen, I'm not sure. So, over here, there we go. Box it off, there we go. 1 over, oh, not 1, we want 2 now. 2 over the square root of 9 minus 4x squared. Perfect. All right, that's job done. That's example number 1. Where's my eraser? Let's get rid of it. Okay. Example number 1. Only one more example for this video. We're going to get it done in lightning time. That'll be the quickest one ever. Y equals inverse tan of, I've done basically the same thing here. All right, let's just do it again. 3x over 2, that's fine, whatever. Okay, so the rule is a on a squared plus x squared. Okay, so my a in this case is going to be the same as, oh, I'm using small letters here. Often I use big letters, but not today. X over 2 over 3. Okay. Okay, so arctan of x on 2/3. So dy dx, we won't do as many steps this time. Let's just do a, which is 2/3, over 2/3 squared. We can do that in one step. Plus x squared. We get the common denominator. Flip the other bit up to the top, so I've got 2/3 times 9 over 4 plus 9x squared. 9 over 3, so that's 6. 6 on 4 plus 9x squared. Done. That's it for this video.